Hi and welcome to this video File Analysis Tools. In this video we are going to take a look at how to analyze files, establishing if they are malicious or not, the type of data they contain and extracting their embedded metadata. In particular, we are going to analyze executables, image and document files, using different tools pre-installed on Kali Linux. Static file analysis is an important topic of digital forensics and is fundamental in malware forensics. We are not going to deal with malware forensics in this video, but the first thing we would like to know when analyzing a suspicious file is if it's malicious or not. Therefore, we could scan it with ClamVu, the antivirus scanner installed by default on Kali Linux. First, we run the freshclam utility to make sure that the antivirus signature database is updated. Then we execute clamscan, the antivirus scanner, on this suspicious file. On Kali Linux, a graphical front-end is also available, that is clamtk. In this case, clamscan has detected a Windows Trojan program. Even if the clamscan doesn't detect any threat, we could not definitely say it's not malicious for sure, so we shall better submit the suspicious file to a free online scanning services like virustotal.com that scans files using many antivirus scanners. File analysis comprises two phases: content or type identification and metadata extraction. The content identification implies detecting what type of data the file contains. On Windows, the type of a file is usually associated with its extension, but is a suffix of the file name of three letters, such as, for example, .x, .doc, and so on. On Unix-derived systems, instead, file may not have and usually don't have any extensions. So we can't simply rely on the extension to determine the file type, also because anybody could change the extension without affecting its structure and contents. A much more reliable way to identify a file is by means of a so-called magic number, that is a hexadecimal value embedded in the file header. Each type of file has a different magic number. On Unix-derived systems, magic numbers are listed in a compiled binary file. That on Kali Linux is usr/lib/file/magic-mgc. To see a list of magic numbers of common file types, we can refer to this page on Wikipedia. For each file extension, the corresponding X signature, that is the magic number, is reported. These magic numbers are used by the command line tool file to identify the type of a file. As an example, we can execute a file on the malicious file we have scanned previously with ClamVu. Despite its extension that appears to be that of a PDF document, in reality the file tool shows that it's a Windows portable executable file. Another method to identify a file is inspecting it with a X viewer or editor, like XXD or a graphical interface editor. We open the same file with XXD. And we can see that the first column on the left represents the offsets, The next 8 columns are the hexadecimal representation of the data contents. Each column being representing 2 bytes, and the right side shows the ASCII text representation. We can notice that the magic number for this type of file, for a portable executable file, is the 2 bytes, that is 4D5A, and that correspond to the string MZ on the right. An unknown file could also be identified on the basis of the National Software Reference Library reference dataset, which is a large database of hashes of files. The database can be freely downloaded at this page. NIST doesn't provide a tool to query this database. There is a command-line interface client program called NSRL Lookup to query the reference dataset database, and it's available on GitHub at this address. There is also a National Software Reference Library hash search engine that supports searches via hashes like MD5 or SHA1 or by file name, submitting one file at a time. And this search engine is available at this URL. Another very useful tool for file analysis is strings, which is also installed on every Unix Linux system. This tool displays the strings of printable character that it finds in a given file. We can execute the strings on the same malicious file, redirecting the output to a text file. Reading this output file, we can retrieve useful information, such as, for example, the Win32 API function called by the program, and also eventually URLs and IP addresses. We could also perform a keyword or regular expression search on the output file, using, for example, the grep utility.
Now we cover an open source multi-platform application that includes all the functionalities of the tools we have covered so far and supports a wide range of file formats. It is called Detect It Easy. It comes with both graphical and command-line interface versions and can also be run in a Docker container. It is a complete and valuable tool that displays very detailed information about files and could be downloaded from its GitHub page. We first briefly cover the command line tool, which is like a more enhanced version of the file tool and could be useful especially for batch processing of files, through scripts, for example. To show its usage, we analyze the same suspect files that we have looked at in the previous example. We can see that the output is like of the file that of the file tool, but it gives more detailed information, for example, about the linker, the compiler, and the tool used to build the executable. Now we explore the GUI version that we launch with the die command. We open the same suspect file as before. And we can see that it returns even more detailed information than the command line version. For example, the file size, the architecture, and so on. If we click on the advanced options, we can get even more detailed information about the file that could be useful for malware analysis or reverse engineering. If we click on one of these buttons, for example, File Info, it opens a new window where we can see all these informations, for example, the X visualization of the file, the different type of hashes, all the strings contained in the file, the memory mapping of the executable, the entropy that could be an indicator if the file is packed or not, and in this case it seems like it is packed. We can also search for keywords or pattern in the file and have a view of all the sections with the relative info, and the import table with all the DLL that are loaded by the executable. We can also scan the file with Yara rules and with VirusTotal. To scan the file with submit and scan the file with VirusTotal, we first need to get the corresponding API key and save it in the program settings. Here it displays all the detections made by the different antivirus vendors, and we can directly go to the results page on the VirusTotal website, clicking on this button. So we can add more detailed information about the detections and the details of the file.
When analyzing a Windows system, we might want to find every executable on the system, even those that may not have an executable extension, without manually inspecting every single file. To do so, a valuable tool comes to our rescue, that is misidentify, that lists executables in a given directory. By default, the program reports only the file names of executables of which the extensions don't match one of the known executable extensions, for example .x, .dll, .sys, and so on. In this example, we assume having mounted under the mnt/suspect directory the Windows image we have used in the video number 2 of this section about registry analysis. So we run misidentify, specifying the R option to also scan the subdirectories recursively. We scan the Windows /system32 directories. As we can notice, the files listed don't have a known executable extension. Specifying the A option instead, all the executables are listed regardless of their extensions. Now we are going to cover the analysis of image and video files. There are many image and video file formats. The most popular image formats are JPEG, PNG, BMP, GIF and TIFF, while the most common video formats, also called containers, are WMV, MP4, MOV, AVI and FLV. We are going to see how to extract metadata from this type of files. Metadata, as we have already seen with file systems, are data about data. In this case, metadata are embedded within the file itself. The most common metadata for image files is EXIF, Exchangeable Image File Format, developed to record metadata about the capturing camera, such as, for example, the make, model, serial number, the camera settings, date and time, and the GPS data for geolocalization. A tool to extract metadata from image files is exif2. The use is quite straightforward, as we supply the image file with the PA options to display more verbose information. We execute exif2 on a sample JPEG image file. As we can see, the output shows very detailed information about metadata of the image, like the settings of the camera, the information about the camera and its settings, detailed information about the image itself, and also GPS data. Another tool that is able to extract metadata not only from image, but also from videos and other common file formats is exif2. exif2 is not installed by default on Kali Linux, so we have to install the relative package with the usual command apt-get install. In my case, it says the package is already installed. We can run exif2 on a sample video file, on a MP4 video file. The metadata extracted are similar to those of the previous example, but specific to a video format, such as, for example, the frame rate, the audio properties, and so on. When looking for images on a Windows system, it could be useful to analyze thumbnails and associated metadata. Windows stores the thumbnails of images of a certain directory in the thumbs.db file. Even when images are deleted, the thumbnails and the metadata associated persist in the thumbs.db file. This kind of data can be extracted using Vinetto. For the sake of brevity, we are not going to run the tool. We only show its options. By default, Vinetto extracts the metadata contained in the thumbs.db file. If we specify the O option, it extracts the thumbnails to the corresponding output directory. while the H option is to write an HTML report to the same output directory. Kali Linux also provides tools to analyze documents, PDF files in particular. PDF, a portable document format, is, together with the Microsoft Office format, the most popular document file format. PDF metadata can be extracted using exif tool. We execute it on a sample PDF file. The output displays the relative metadata, such as the modification and access date and time, the PDF version, the software used to create it, the page count, and many others. There are also tools specifically designed to analyze PDF files. The first tool we cover is PDF ID, that scans the PDF for a given list of strings and counts the occurrences. We execute a PDF ID on a suspicious PDF file. As we can see in the output, it displays the occurrences of the objects and streams found in the PDF file, and also the sections of JavaScript code within the document. Malicious PDF files very often contain JavaScript code, but is usually associated with an automatic action that launches it when the document is viewed. This automatic action is displayed in the PDF ID output as open action. PDF ID also shows an embedded flash code under rich media. If a PDF like this looks suspicious, we might analyze it more deeply with ppdf. This tool allows us to inspect the objects and streams that form a PDF file, and also any JavaScript code. We execute ppdf on the same file with the I option to launch an interactive shell. The output gives this error because we must specify the full path to the file, otherwise the tool doesn't find it. We can see in the output that the PDF has 15 objects, of which 9 and 13 are encoded streams. In particular, the object number 14 contains JavaScript code. ppdf also provides the feature of inspecting more deeply a particular object. To do so, before we can list the commands available in the interactive shell with the help option, with the help command. The command to inspect the object is object. So we execute object, and we give as a parameter the number of the object 13. The output displays the JavaScript code contained in this object that very likely contains a shellcode. Other very popular document formats are Microsoft Office ones. Kali Linux doesn't provide tools specifically created to analyze these files. EXIF tool also works with this type of files, and we can execute it on a sample Word doc. The output displays metadata information like the application used to create the document, the number of pages, words, characters and paragraphs, the title, subject, description, and the number of revisions. We could also view the metadata of this document, opening it with the LibreOffice program, and then clicking on File and Properties and selecting the various tabs.